So this is the radiators that I'm using for my solar collector to heat up the water. So they are both used damaged radiators from the car. I got them for free. I had to fix them with some epoxy, like on this case, but that was cheap fix and it will work for this purpose. So few inlets and outlets that I had to fill with epoxy because I don't need them. So here is one, there is another one, and then basically supply side and return side. So here I have used 1" to 3/4 reducer, also put it on epoxy. On this side where I need to hook them up both, I'm just using 1" pipe thread on epoxy to the barb fit into the hose on both sides, and same on that side, just a reducer from 1" to 3/4 where I will connect 90° and a piece of pipe. So this is the solar collector with the radiators inside. They're not hooked up to the water yet, but having it sitting outside facing south, basically from 1 p.m. till 4 p.m. the temperature was staying at 130 degrees Celsius. So running experiments through the day, I was able to heat up this solar collector to 130 plus degrees Celsius, and it has some negative outcomes. So I had a piece of XPS insulation and it just melted. The polyiso stays fine, so I'll need to replace this piece. The plastic fittings on the radiators melted too. You can see that this is melted completely. That one is squeezed. So we will need to make sure that either we replace those with metal ones, or we keep this system filled with water whenever it stays outside. So since all my plastic fittings got melted, I have replaced everything with the galvanized steel. So you can see 1" elbow, and it has thread that goes inside. Put it on epoxy. So 1, 2 in here, barb fitting will be connected to that one, and the other one same thing. I think it's called street elbow, 90 degrees, 1". So now I will need to use reducers on the inlet and outlet, reduce it to 3/4, and then I can connect it to the hose. So I got my solar collector tested for a couple of days. So basically have it installed facing south and roughly at 45 degrees. I have a pool, so I was heating up water in the pool, and through the day it showed quite a good results. In general, in a peak hour closer to noon, 1 p.m., it was giving out around 1300 watt of heat. So that was calculated, and I will show you the graph. In general, that's basically 3 times as much as my solar panel do, roughly the same size. So quite happy with the result. And in terms of this pool, it has 4 cubic meters of water inside, so it was able to heat it up roughly 1 degree Celsius per hour. So if I run it all day, I could bring the temperature up from like plus 18 to plus 24, 25, closer to 4 p.m. So next step will be to move it on the roof and install it permanently. Also, I want to get this glass around all sealed up so there is no air movement. To conclude, the project I believe is quite successful. we are generating 1300 watt of power in a peak hours, considering that it's 3 times as more as solar panel does, and solar panel is roughly 20% efficiency. So this is just about 60% of efficiency. Obviously lots of room to improve, but for this purpose it works quite well. So I think I will stop on that, at least for this year. We'll get it mounted on the roof. So on the graph we can see performance of the solar collector in watts for the 2 days. First day we had a little bit of clouds, so the performance was not as good as on the second day, and in the peak hour between 1 and 2 we were producing 1565 watts of energy from this solar collector. So in general, I think it's amazing results for the homemade solar collector. So please like and subscribe, and as always, have a sunny day.